The null hypothesis, like I said earlier, is a claim that nothing has changed in the population parameter or the parameter that is assumed to be true. Now, from this particular question, the null hypothesis is 10%. Null hypothesis is 10%. Is the claim by the Board of Education. All right. So the research hypothesis is denoted by the research hypothesis denoted as HA, and is the population parameter that the researcher is aiming to gather evidence in favor of. So it is the hypothesis that the researcher is aiming to gather evidence for. Right. From this particular question, we have that our H naught in the true population proportion, to be equals to 0.01. That is 10%, 0.01. And our HA P is now a high school counselor in the same district claims that the percentage is what? Too high. So the percentage is too high, meaning that the population parameter is less than or equal to 0.01. Less than 0.01. All right. This is the first step. The first step is to state the hypothesis, and this is how we state the hypothesis. So this is the first step to writing hypothesis. All right. The second step is to test the collected data. To test the collected data using the appropriate sampling technique. Test the collected data using appropriate sampling technique. This is something that you should have done before now. How to collect data, how to collect data and gathering of data, and then so gathering of data is not something we are supposed to do at this particular stage. It's a knowledge that is a prerequisite to this hypothesis. Gathering of data is a prerequisite to this. So we are just going to go straight to applying we'll use the sample statistics, which is our S prime and P prime. S prime and P prime. We use the sample which we have used to estimate the parameters, so we can use it to construct the confidence intervals. Then we convert them to Z scores or T scores. We convert them to Z scores or T scores for our hypothesis testing. So after gathering your data, then you get your population, you get your sample statistics, and then you construct your confidence interval and convert to Z scores or T scores so that we can use it for our hypothesis testing. Now, for the Z score, we have Z is equals to 3 prime minus P all over P 1 minus P in. So this is the formula for the Z score. Formula for the Z. This is the formula for the Z score. Z is equals to this. This is the formula for the Z score. Now, our P prime is the is this is our P prime, which is 0.085 minus 0.2. 10% is 0.1 minus 0.1 over square root of over 50. This is your n number of samples. Right, so this is how to get our z-scores. So from if you impute this with your calculator, you have that z is equals to minus 0.3536. 0.3536. That's our c. 0.05. So we are going to draw normal distribution to this. Minus 0.3536 is at the left hand side, so it should be somewhere here. Left hand side. So that's the. So we observe that 0.35 value standard deviation is to the left of the normal distribution. Right. So the third step is to analyze the data. To analyze the data to determine which of the two hypotheses the data support and write a conclusion in context. The third step is to analyze the data to determine which of the two hypotheses the data supports and write a conclusion in context. Now, the null hypothesis states that what the status quo, that is the value of the parameter, is assumed to be equal. Throughout our hypothesis test, the null hypothesis is always assumed to be true. So throughout the whole process, we assume that the null hypothesis is true. The hypothesis test therefore examines whether the data collected are consistent with this belief. So the data we collect will either back up that this hypothesis is true or it should be rejected, right? If the data disagrees sufficiently based on what? Based on the level of significance. So how we know that this data disagree is based on our level of significance, which is alpha equals to 0.02. Our level of significance will be based on the alpha, which is equals to 0.02. So with the null hypothesis, then we reject the null hypothesis in favor of the alternative hypothesis. So if the data disagrees sufficiently with the null hypothesis, then we reject the null hypothesis. And once we reject the null hypothesis, we favor the alternative hypothesis, which is the research hypothesis. So in hypothesis testing, we are testing that the null hypothesis is true. If it is not true, we reject it. We reject it in favor of the alternative hypothesis. So we usually say reject or not reject. Reject or not reject. That's the usual conclusion. So yes, so from The conclusion can be found with using two methods. We are going to use two methods to determine the conclusion. The first is to use a rejection region. To use this usually from based on a critical value compared to the test statistics. Then the test statistics is usually the z-score. So we are talking about z-score. The critical value is gotten from the alpha, which is 0.03. So what do? We using Excel, we can find the the normal standard deviation to the alpha value, which is 0.0. So if we type in your Excel that num.s num.s input 0.02 num.s put inval 0.02, we are going to get, yes, using Excel, using Excel, I'm going to get this is equals to minus 2.054, minus 2.054. It's going to be minus 2.054. All right, so if you look at to identify minus 2.054 in our normal distribution, we have it is somewhere here, minus 2.054. And so this is our rejection region. This is our rejection region. Rejection region. This is our rejection region. And we can see that this line, minus 0.3536, does not fall in our rejection region. So we will not reject the hypothesis. We will not reject the null hypothesis. We will not reject the null hypothesis. So our conclusion will be we will fail to reject the null hypothesis. All right. So this is for it. In some cases, our research hypothesis could be greater than or not equal to. So in giving out hypothesis, stating our hypothesis, our null hypothesis should always equal to, but for the research hypothesis, it could be less than or greater than or not equal to. It could be less than, greater than, or not equal to. But the null hypothesis is always equal to. So now for the second method is to determine the probable p-value of finding a random sample. So given that the null hypothesis is true, so we compare our finding to our level of significance. Now, if p is less than alpha, then we reject the null hypothesis. If p is less than alpha, we reject. And if p is greater than alpha, we will not reject. So from here we can see that since our critical value, which is minus 0.3536, our z-score, which is minus 0.3536, did not fall in the rejection region, we will not reject the null hypothesis. So here we will not reject the null hypothesis. We will not reject the null hypothesis. All right. Now, in this second method, where our z-score is minus 0.3536. Now, using using to p-value. Our p-value is gotten from z, which is less than 0.3536, z less than minus 0.3536, which is equal to 0.361. How do we get that? You type in your Excel, num, you get type num dot s dot dist 0.3536. We get that. So since our p-value, which is 0.3618, is 0.3618 is greater than 0.02. Value is greater than alpha. 0.3618 is greater than 0.02. So we fail to do what? We will not reject the null hypothesis. So we see that in both cases, both the first method and the second method, using the rejection region and looking for the p-value, we fail to reject the null hypothesis. So our conclusion should usually contain three things. The conclusion should usually contain three things. Number one, our conclusion will contain whether we reject or we fail to reject the null hypothesis. So it should be stated clearly whether we reject or fail to reject the null hypothesis. Secondly, the data that led to our conclusion would also be available. And then third, what reject or failing to reject means. So what does rejection or failing to rejection means? Now for this particular example, we'll say from the first method, we have that since our z-score of minus 0.3536 falls above our rejection region, which of minus 2.054, our rejection region is minus 2.054, we fail to reject the null hypothesis. Therefore, there is insufficient evidence that less than 10% of sequelars consider dropping out of school. So there's insufficient, that is the third stage, what rejection or failing to reject means. So because we fail to reject, it means that there is insufficient evidence that less than 10% of sequelars consider dropping out of school. So that's our conclusion. So this is all for the introduction to hypothesis. In our future classes, we'll go in depth into these three steps and we'll look at our t-test as well and the chi-test in hypothesis or writing and in hypothesis. So thank you.